while you're getting out that note packet, just a quick overview of a 4-day week this week. Okay, so you guys don't have school on Friday, so you got that going for you, which is nice. So today we're going to do 9.6. Tomorrow we're going to do 9.7. They're much in the same, talking about centers and spreads and all that fun stuff and shapes of data, etc. Wednesday of this week we're going to review Unit 9. Then on Thursday of this week we're going to have the Unit 9 test. Okay? Right? So Unit 9 test will be Thursday of this week, and then you have a nice 4-day weekend, which hopefully is going to be nice. Like this past weekend. Really nice up until yesterday morning. Then it started raining. But the sun's out now. So that's good. Let's have a positive. Sun's out now. Okay? Okay. The sheet that you picked up today, that's going to be a supplement to your notes. We're going to jump into that one here after we get done with page 38 in your notes. We're on page 38 in your notes. And then if you haven't taken Friday's quiz yet, make sure you take Friday's quiz ASAP. So on page 38, you've got 3 graphs. What I would like you to do is first off, kind of draw your axes middle-ish on all 3 of those graphs, just to make it easier on you. Then we can see all of those things. On number 3, draw it down a little bit lower. The horizontal one, draw it down a little bit lower like this one on number 3. Okay? All right? And then I would like you to graph those 3 functions, please. Go. I'll give you a couple of minutes to do that. All right. Let's make an absolute value t-chart. What shape is an absolute value graph? Helps to know that before we start. What shape is an absolute value graph? What shape is an absolute value graph? Giving you 3 different clues for it. It's what? It's a V. So if your graph doesn't look like a V, you did it wrong. Okay? What does that mean for us when we're doing a t-chart? We have to find that V, right? Okay? All right? So let's go with 0 is always a good one to start with. Let's go with positive 3. And then let's go with negative 3. Okay? So we're plugging in 0. 0 plus 3 is 3. Absolute value of 3 is 3. Minus 5 is negative 2. Have I found my V yet? Nope. Okay. Positive 3. 3 plus 3 is 6. Absolute value of 6 is 6. Minus 5 is 1. 3 comma 1. Have I found my V yet? Nope. Okay. Negative 3 plus 3 is 0. Absolute value of 0 is 0. Minus 5 is negative 5. Have I found my V yet? Yea or nay? Nope. Okay. All right. Which way should we go? Should we go left of negative 3 or should we go right of positive 3? Left of negative 3? Okay. All right. Let's go to negative 4 then. Negative 4 plus 3 is negative 1. Absolute value of negative 1 is 1. Minus 5 is negative 4. Have I found my V yet? Did we find the V yet? You got a 50-50 shot. Did we find the V yet? Do we need to do some more jumping jacks this time? Right, then we better start asking. We either start saying yes or start saying no. Yay or nay, did we find it? Yeah, we did, because now it's going up again, right? Okay, it made a turn. Okay, so it's going up. So we did find our V. So there's one side of our V. There's the other side of our V. Can I graph number 2 as is? Or do I need to make a T-chart? Or do I need to do something else? Distribute the -2 in. Okay? Alex, what am I trying to do with that then? What am I trying to make it look like when I distribute? Or you know, what am I trying to make it look like when I distribute the -2? Y equals mx plus b, because then I know the slope and I know the y-intercept. So if I distribute my -2, I got -2x plus 12 plus 1. So I get h of x here equals -2x plus 13. So that means I'm going to go up 13. 1 and 2, 3 and 4, 5 and 6, 7 and 8, 9, 12, 10, 11, 12, 13, all the way up there. Uh-oh, we're off my graph. Now what? Don't do anything? Hold up shop? Go on with our lives? Or what can we do? We could change the scale of our graph. We could also move this horizontal asymptote down, right? We could change that. Okay, what if we don't have it? What if this was a locked-in graph on a piece of paper? What could we do? We could still make a T-chart, right? Okay, all right, so if I'm still making a T-chart here for this one, I know that I go through the point 0, 13. Then what happens when I go 1 to the right? What happens to my y value based off of my slope? How many? 2, right? Because the slope is -2. So my y value would become what? 11. Am I on my chart yet? No, because I have stopped at 9. Mine stopped at 9. I don't know what yours stopped at. So let's go over another one. 2. Where am I at now? 9. Now I'm on my chart. 3, 4, 5, 6, 7, 8, 9. 3. 4, 5, 6, 7, 8, 9. Okay? What can I do in number 3? Lauren, make a T-chart. Kind of good information that I gave you at the start, huh? What values do we want to put in our T-chart? What do we want to start with? Roundest number you can think of. Then what? What would we do next? 1? Maybe 2? Okay. If I plug 0 in, 3 to the 0 power is 1 times 2 is 2. If I plug in 3 to the first power is, times 2 is 2, 3, 4, 5, and 6. If I plug in 2, 3 to the second power, 9 times 2, 18. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, way up there. Not a straight line, a curve. Yeah. Good times. When in doubt, what can you always do when you're graphing a function? You can always make a t-chart. You can always plug in values into your function. Yeah. Always, always, always. All right, so now we're on a supplemental sheet from today. So we're going to be talking about center, okay? So we're going to be comparing means and medians. What's a mean? Average. What's a median? Middle of the data. Okay, so we're going to be comparing those two between those two, or between two different sets of data. Okay, spread. That's going to be more of your range of values, how dispersed your data is amongst everything. Okay, and the shape, we've got 3 choices for shape. We've got symmetric. We've got skewed left, and we've got skewed right. Okay. What does symmetric means? Or mean?
They're like all the same.
Nope.
Maybe
That is, well, what did we call that last week? We did have a name for that. It wasn't S word. Well, what did we call that last week? There was a name for it. Oh, why can't I think of it? Uniform, not an S word. You know, that other S word. Yeah. Uniform. Okay? All right? What does symmetric mean, though? And? Okay, yep, keep going. Keep spitballing this. He's going to jump in, he's going to jump on your coat wings. So if we go over one, it goes down the same amount, right? Is that what you're saying? Okay, go over another one, it's uniform in that way, right? Okay, looks like, anybody remember what I called it last week? A bell, looks like a bell. It's called a bell-shaped curve, okay? Skewed left means what? All the data is over on the right side, okay? Skewed right means all the data is over on the left side, okay? All right, so we're going to talk about those things, and we're going to compare those things today. So, in the first one on your supplemental sheet, Okay, so we've got data set 1, Williams class, versus data set 4, Anderson's class. Okay, so we need to describe the center, the spread, and the shape for both of them, and then we're going to compare them. Okay? So in terms of the center, this is telling me that the center is the average is at 73.21, which would be kind of right in there, right? Is that very centralized? No, not really. Okay, all right. What's the spread of this data?
40.
Do we know for a fact that it's 40? Why not?
Because it's like, it's not telling you the exact number, it's just telling you the amount in 60 or 65.
It's telling me that there's 8 values between 60 and 65. They could all be 64s, right? Okay? So instead of saying exact 40, that's why I wanted to be exact, instead of saying exact 40, we're going to say approximately 40, because we don't know. It's a histogram. We just don't know, right? Okay? So the spread here is going to be approximately approximately 40. Okay? What shape would you put this one at? Skewed right? So since it's skewed right, that means that the majority of our data points are lower, correct? Lower, because they're on the left side. Okay? Let's jump over to Anderson's class. This is now telling me that it's got a higher mean at 80.27, which is going to kind of be like right in there. More applicable to the center, yes? Okay. More applicable to the center. Okay. Approximate spread, because again, it's a histogram, so we can't necessarily say for sure. Twice I didn't do 2 P's in approximate. Our approximate spread is how much? 50? 50? Okay. Shape. Majorly skewed, slightly skewed, weakly skewed. Okay. I would say I would go there too, because it's not like the Williams class, right? Where it was it was a hard skew. Okay. So I would say a slight skew here. All right. I'm going to give you 35 seconds at your table to determine which class. What is it? Is it better, higher scores? What? I forget what it says. Which of these classes do you think did the best? Okay. 35 seconds. Go.
Anderson's class, yes, this goes over.
What are we thinking? Which of the 2 classes did the best? Which one? Why? Okay, so the average is higher. Okay. Anything else for why Anderson did better?
Skewed left.
So that means it's skewed towards the higher end, whereas the other one was skewed towards the lower end? Yep, I'd go Anderson there too. All right, let's go to the next one. Croft versus Herlea. What are we thinking? So median here would be what? $75. Okay. Median here would be what? What do you think for Herlea? Like 82-ish? Somewhere in that range? I'd go with 82. Okay. Approximate mean. Just take a guess. What do you think? $71, $72-ish, somewhere in that range? Yeah? What would you go for an approximate mean over here? $82 or $81? $80, $81, somewhere in that range? Yeah? Spread. What's the range on the left one? Range on the left. On the left? Would it be 60? Because that 40's in there too yet? Range on the right. 40. Shape. Shape. Skewed right. Slightly. Shape on the second one. I'd go with a very slight skew left. Which class did better? Why? So it's got a higher median, right? It's got a higher average. Yeah. Okay. All right. Yeah. It's its lowest of the lows was 60. If you take out that 40, the lowest down here, then it still is 55, so it's got a higher low. Yeah, I definitely go with Herlea's. Huh? At your table now, I want you to do the back side together. Okay? Go for it. First one, means were given to us. Approximate median is somewhere on the left one, between 80 and 85, because we know how many data points there are in those buckets. We can figure out the approximate location of it. Okay. The median on the right one is in that 70 to 75 bucket. Spread. Jones's class had a larger spread, but higher scores. Okay. Williams had a smaller spread, but also had lower scores. Okay. One skewed left, one skewed right. Which one's better? Jones? Yeah, I'd probably go with Jones on that one also. Got the means again. We got 5, 10, 15, 20, 25. So I need to go 5, 10, 15, 20, 25, and 8 is 33. So you go to the 17th. So the median is right here. Okay. 1, 3, 6, 10, 14, 19, 26, 32, 35, 37. So that's going to be the 19th. 1, 3, 10, 14, 19. So that's going to be right here at in that 80 to 85 range. Can't tell exactly. Spread here is 30. Spread here is approximately 50. Shape here is that uniform. I would go definitely with uniform there. And here, slight skew to the right, or excuse me, slight skew left. Which class did better? Which one? Sorry, I don't even know what the names are. Lemons? Lemon versus Anderson? Lemon? Smaller spread? Higher median? More, yeah, I'd go lemon there too. Yep. Yep. All right. Let's take a peek at our homework for tonight. Oops, just went past it. So on page 45, it doesn't give you what the explicit equation is for that one. So we would like you to graph this explicit equation, please. F of x equals 4 plus 2 times the quantity x minus 3. for number 1. For number 2, we would like you to graph this one. Half of x equals 8 times 1/2 to the x power. Let's see if I can get those both. Oh, I can't quite get them both on the same. Everybody got them written down? Okay? Because those are the ones that you're going to have to graph. So make sure you write them down. Okay? Got them? All right, so we're graphing those two. Then we're jumping into problems 3 through 5 have 2 different data sets. So you got data set A and data set B. We're talking about find something that B has greater than A. Find me something, data set A is something, and maybe we talk shape there on that one. That might be a good idea on 4. And then on 5, here's the data, and data set A has a greater something. Okay? Here is the 5-number summary for both of those. That might actually help you out in going back on those last 3 to determine what's what. Okay? But then for number 6, you need to make 3 comparisons. I almost said 3 comments. 3 comparisons based off of those. Box plot X, box plot Y, find median range in IQR, median range, oh, so that's just, okay, so find the median range in IQR for both of those. Which class did better in your assumption for number 9? You can handle all those. Box plots again for cities, city D and city E. Which is the colder city? Why? Do they ever experience the same temperature? How do you know? Shape, center, and spread then on both of those. Okay. And would it be better to show it in a histogram form? And that, ladies and gentlemen, is your homework.